Our galaxy is full of planets you would never survive. Boiling gas giants that glow hotter than stars. Worlds where it literally rains molten metal. Planets ripped apart by their own suns or drifting alone in absolute darkness. We used to think our own solar system was strange enough. Rocky worlds, gas giants, icy moons, storms the size of Earth. But compared to what we found beyond it, Jupiter, Venus, even Mercury start to look almost friendly. Astronomers have now confirmed thousands of exoplanets in the Milky Way. Many of them are familiar, at least on paper. But a handful are so extreme that if you could stand on them for even a second, they would kill you in ways you are not prepared for. In this video, we are going to travel to some of the most terrifying exoplanets we have ever found. Worlds where the sky burns, where the ground melts, where night never comes, and where even time itself seems to break. Let's start with something simple. A planet that looks like a gas giant, but is hot enough to outshine actual stars. If you could somehow visit Kelt 9b, you would not really see a planet. You would see something that looks like a mistake the universe made while trying to build a star. Kelt 9b, discovered in 2016, orbits a blue-white star about 670 light-years from Earth. Its star, Kelt 9, is almost twice as hot as our Sun and several times larger. The planet itself orbits so close in that its entire year lasts less than 2 Earth days. At that distance, the day-side temperature reaches around 4,300 degrees Celsius. That is hotter than many red dwarf stars. On Earth, atoms and molecules are stable. On Kelt 9b, the heat is so brutal that many molecules are literally torn apart. Astronomers studying its light see evidence that its hydrogen atmosphere is being boiled off into space, stripped away, and dragged back into the star at a rate of tens of thousands of tons each second. Imagine hanging in the sky above its day side. Below you is not a cloud deck and not a solid surface, but a glowing, churning ocean of gas. A planet that behaves more like an exposed stellar core than anything we would normally call a world. Kelt 9b is doomed. Over time, its atmosphere will be completely ripped away, leaving only a scorched core to be eaten by its star or swallowed when the star expands into a giant. Another extreme example is WASP-12b. This gas giant orbits its star once every 26 hours. It is so close that the star is actively stretching it into a football shape and slowly tearing it apart, feeding on its atmosphere like a vampire sun. As extreme as these are, temperature alone is not enough to make a planet terrifying. Sometimes it is what falls from the sky. On a distant world called WASP-76b, umbrellas would be useless unless they were made of something thicker than steel. WASP-76b lies about 640 light-years away in the constellation Pisces. It is what astronomers call an ultra-hot Jupiter, a gas giant bigger than Jupiter, but orbiting far closer to its star than Mercury does to the Sun. It takes just 1.8 Earth days to complete a full orbit. Its day-side temperature is around 2,400 degrees Celsius, easily hot enough to vaporize metals. The planet is tidally locked, so one side always faces the star, while the other is trapped in permanent night. Using the espresso instrument on the Very Large Telescope, astronomers looked at starlight filtering through WASP-76b's atmosphere during transit. They found a clear signature of iron vapor. The best explanation is disturbing. On the day side, iron in the atmosphere is turned into gas. Supersonic winds carry that metal vapor around to the night side. There, in the relative cool of about 1,500 degrees, it begins to condense, forming droplets that fall back down. On this world, it rains molten iron. If you could float in the dark hemisphere, you would be surrounded by an atmosphere hot enough to melt stone, hammered by glowing metal droplets falling from black clouds you cannot even see. Another terrifying weather world is HD 189,733b, about 64 light-years away. This is also a hot Jupiter, discovered by radial velocity and transit measurements. Its deep blue color once made people imagine oceans. That blue does not come from water. It comes from tiny silicate particles, the same material that makes up glass. Winds on HD 189,733b are thought to reach up to 7,000 kilometers per hour. Those winds pick up silicate particles and hurl them sideways across the atmosphere. The result is a world wrapped in storms of glass, with shards flying horizontally at several times the speed of sound. On Earth, a storm like that would strip a city down to its foundations. On HD 189,733b, it is simply the climate. But a planet does not have to have extreme weather to be terrifying. Sometimes all it needs is the wrong orbit. Here in our solar system, Mercury is the speedrunner. It completes one lap around the Sun in just 88 days. That seems fast until you meet the ultra-short period worlds. Planets like K2-137b, discovered with NASA's Kepler K2 mission, finish an entire orbit in just 4.3 hours. For a planet to orbit that quickly, it has to be incredibly close to its star, so close that it practically skims the stellar surface. K2-137b is roughly Earth-sized. At that distance, it almost certainly orbits inside the star's extended outer atmosphere. It is being roasted from above and dragged from below. The star's intense gravity pulls more strongly on the near side of the planet than on the far side. These tidal forces stretch the world, heat it from the inside, and can crack its crust, slowly grinding it down, orbit by orbit. Another example is Kepler 70b, which orbits its star in about 5.8 hours. It may be the surviving core of a once larger gas giant that was stripped bare when its star swelled into a red giant. If you tried to visit one of these worlds, you would not be dealing with years, seasons, or even days in any familiar sense. A year would be shorter than most movies. And the countdown to your planet's destruction would already be underway. Being too close is one way to die. Another is to have no star at all. Most of the planets we have found orbit stars. Some do not orbit anything. These are rogue planets, also called free-floating planets. They drift through the galaxy in total darkness, not bound to any star's gravity. They might have formed in normal planetary systems and then been flung out by gravitational chaos early on. Or they might have formed directly from collapsing gas clouds that never became massive enough to ignite as stars. From the surface of a rogue planet, there would be no sunrise and no blue sky. There would be no regular pattern of day and night. The only light would be the faint glow of the Milky Way and the cold glitter of distant stars. You might think that means these worlds are frozen and completely dead. But there is a twist. Because they do not have nearby stars blasting them with solar wind, rogue planets might hold onto thick atmospheres more easily than you expect. If a large rogue world started with a deep, hydrogen-rich atmosphere, it could trap heat from its own interior, from radioactive decay and leftover formation energy. Beneath that insulating blanket, liquid oceans might exist, heated from below instead of from above. Any life clinging to such a world would never see starlight. It would live near geothermal vents, feeding on chemistry and heat in a perpetual midnight. We have already detected several candidates through gravitational microlensing. This technique watches for the brief brightening of a distant star as a massive object passes in front of it and bends its light. Ground-based surveys such as OGLE and MOA have spotted events that seem to be caused by planet mass bodies with no parent star in sight. Dark, silent, drifting through the galaxy alone. Rogue planets are terrifying not because they are violent, but because they are so utterly isolated. But if rogue worlds are frightening because they lack a sun, some planets are frightening because they have too many. On Earth, one star is enough. It gives us a simple rhythm of day, night, and seasons. Now picture a planet with 2 suns, or 3, or even more. In 2011, NASA's Kepler spacecraft found Kepler-16b, the first confirmed planet orbiting a pair of stars. It is about 200 light-years away and has roughly the mass of Saturn. From any hypothetical moon orbiting it, you would see 2 suns rising and setting together, sometimes overlapping, sometimes separated in the sky. It sounds beautiful, but the gravity in such systems is complicated. In a binary star system, both stars orbit a common center of mass. A planet like Kepler-16b orbits that center as well. Subtle gravitational tugs from both stars can make orbits wobble and slowly change. Seasons and climate become far less predictable. We have also found planets in systems with 3 stars, and computer models suggest it is possible for planets to survive in even more complex star systems. On some of these worlds, there could be long stretches of time with no true night at all. As one sun sets, another rises. The sky glows dim but never fully dark. If one of those suns is a massive, short-lived star, your climate is not the only problem. You are living next door to a future supernova. We know that a nearby stellar explosion, within a few dozen light-years, would be catastrophic for Earth. It could strip our ozone layer and blast the surface with radiation. On a planet deep inside a multi-star system, that risk is even higher. Life might still be possible there. Stable orbits do exist. But your sky would always carry the threat of sudden, cosmic disaster. And if that is not unsettling enough, there is a planet whose very shape hints that something is deeply wrong. Saturn's rings are one of the most beautiful sights in our solar system. Now imagine a ring system so huge it would stretch almost from the Sun out to Venus. That is what astronomers think may surround a mysterious object known as J1407b. In 2012, researchers studying a young star called J1407 noticed that its light dimmed in a very complex way. Instead of a simple dip, there were many dips of varying depths spread over weeks. The best explanation is that something massive, possibly a giant planet or a brown dwarf, passed in front of the star carrying an enormous system of rings. By modeling the pattern of starlight, scientists estimated that J1407b's rings could be around 200 times larger than Saturn, spanning tens of millions of kilometers. From the surface of a hypothetical moon orbiting inside those rings, the sky would be carved into bright bands stretching from horizon to horizon. Sunlight would filter through stripes of ice and rock, casting shifting shadows across the landscape. But this beauty comes with a warning. Ring systems that large are probably not stable for long. They may be the shredded remains of moons torn apart by gravity, or the raw material for moons that have not yet formed. Live there long enough, and you might watch new moons coalesce from the sky itself, or see them pulled apart again and ground into dust. A world with a sky that is literally coming together and falling apart above your head is breathtaking and deeply unnerving. We have only visited a handful of worlds in this tour. Planets hotter than stars, like Kelt 9b. Gas giants where iron falls as rain and glass flies sideways through the air. Rogue planets wandering alone in eternal night. Worlds bathed in the light of multiple suns. Giants wrapped in rings big enough to swallow our entire solar system. And we have barely started looking. Most of the exoplanets we have discovered so far are simply the easiest to detect, the big, close-in, dramatic worlds that shout their existence at our telescopes. As instruments like the James Webb Space Telescope and future missions come online, we will find more of these hellish extremes and also smaller, subtler, perhaps even habitable planets hidden among them. For now, all we can do is observe from a safe distance and imagine what it would feel like to stand on the surface of a world no human could survive. The universe is not short on terrifying ideas. It has been running these experiments for billions of years. We are only just starting to see the results. If you could visit any of these exoplanets with a guaranteed way to come back, which one would you choose first?